Hey,
Okay.
it's Mike Brennan, and we're doing another MITech TV today. Today is Monday, November 6th. Where has the year gone, Matthew?
I don't know, but it is 5/6 over or thereabouts now.
So anyway,
Absolutely.
we have one of your compatriots coming on here from our first segment from Lawrence Technological University. Why don't you introduce Scott and set this up so the viewers know what we're going to be talking about?
Well, with us today is Scott Schall. He is professor of architecture at Lawrence Tech and someone who's been into the future of housing, sustainability, and issues like that for a long time now. So welcome to the show, Scott.
Oh, thank you for having me. I'm excited to be able to talk about this.
Okay. So tell us a little bit about the project that you are working on now. I know you have you are co-owner and co-founder of a company called Houm, that's spelled Houm, that is about to construct a very unique house on Cochrane Street in Detroit's North Corktown neighborhood. So tell us a little bit about the history of Houm and what you'll be doing in the weeks ahead.
Well, I'd be glad to. Home was started 2019, and it was grounded on research looking into housing. As we all know, we do have a bit of a housing crisis here in the United States, especially around affordable or even cost-effective housing that impacts a lot of low, middle, and even upper middle class Americans. And I was looking at the housing crisis and how I, as an architect, might be able to address it. And one of the things I noticed in my research was how a number of the methods we're using to create housing right now are quite outmoded, haven't been innovated quite a bit in quite a long time. And this stands in sharp contrast to the auto industry or other manufacturing sectors, where there's been just so many innovations over the last several decades, allowing for greater efficiency, reducing waste, improving the kind of product performance. And you just don't see that same thing within the field of architecture. So I immediately started to look at how we might leverage things like generative design and digital fabrication, industrial scale production, anything I can get my hands on to try to figure out a smarter way to build. And that's really is trying to find a way that we can be a little smarter with the manner in which we construct housing so as to make housing more affordable, sustainable, effective, and beautiful. And that's the goal of Houm. And it was founded on that principle. And the house that you referenced in Cochrane represents our very first actualized construction. And so we're very excited about it. It is a sort of proof of concept, I guess you'd say, for a long-standing research agenda. And when we broke ground, I think many of us wondered if it would ever happen, but it did. It did a couple weeks ago. And with any luck, there'll be a lovely family living in there at the end of April.
Okay. So what is it about the fabrication, about the construction techniques used in this house that makes it unique?
Well, first of all, I guess maybe the most obvious is how we're leveraging offsite construction and digital fabrication to really bring the cost, environmental footprint, and time commitment for housing production down. On the average in Detroit right now, for a house of about the quality and size we're looking at, it's about 11 to 12-month proposition to build the house. We are actually going to finish this house in between 6 or 7 months, which would be a sharp decrease in the average. Average housing in terms of price point for the house of the quality we're looking at, it's between 250 to 75, 300. We're going to do ours for under $200 a square foot. And we're going to accomplish that while also increasing substantially the environmental benefits of the house. We are using, and I'll explain the products probably a little later on, but we're using some very innovative products for the building envelope that's going to decrease air infiltration, increase insulation, to the point that the average heating bill right now for this 2,400 square foot house is about $80 a month. That's the estimate currently. We came really close, in fact, of seeking passive house certification and might have been able to get it. But as our first house, we didn't want to overburden this very first concept home with that. But we do think that that is an achievable goal and one that we will go for. Passive house, just so you know, is probably one of the most rigorous standards of certification that houses can achieve. And it is specifically about how well you use the energy infused the house to create comfort for the occupants. So the house itself is predicated, one of the chief innovations is what we call affectionately the core of the house. What we've done is if you look at a home, all of the walls have a certain degree of complexity because you have piping, you might have electrical work, you might have structure, there might be insulation. And in many, many homes, these complex walls are spread all over the house. What we've done is we've consolidated those more complicated walls into the smallest possible footprint, so as to allow the vast majority of the walls that define the home to be a much simpler structure. In order to achieve that, we had to leverage the precision of industrial manufacturing, digital fabrication, so that we could have intertwining pipes and conduit and structure and all of those things where they don't get in each other's way. We can plan it perfectly ahead of time, all without increasing the time associated with building these things in the kind of detailed manner that we're describing. And both the other asset is both that as well as the envelope can be built off-site, which gives an incredible benefit in terms of the timeline. That's how we're able to reduce by almost 50% the timeline associated with housing construction.
So is this
Yeah,
kind of a modular home then, or what exactly is it? I'm trying to understand.
So it's a really good question. It is, well, it depends how large you allow me to consider a module. And that, yes, everything is modular. And so, like, as an example, the building envelope is being manufactured in modules in Cleveland with a wonderful manufacturer working on a product that has a high R value, manufactured offsite, and can be installed upon delivery to site in about 2 or 3 days. So this house will go from basically a slab of concrete in a sea of dirt into a fully formed house inside of 2 or 3 days. This would allow, obviously, all of the subsequent construction to be performed in the dry and climate-controlled conditions, which has all sorts of benefits to both quality control as well as efficiency. So that's a module of sorts. It's a module of a wall, right? And it kind of shows up on site as a 4-foot by 12-foot thing that then is attached to the next 4-foot by 12-foot thing, and off you go. The same with the digitally fabricated core I mentioned. Its flat pack is probably something closer to kind of architectural parlance. If you want to imagine, think of IKEA, right? Where everything shows up in a box, and then you get your handy Allen wrench out and you swear to the gods and you assemble the things, right? And then you always have like a missing bit at the end, but you're fine with that. We hopefully won't have any missing bits as this thing is assembled. But it's the same basic premise where we digitally fabricate everything off-site very precisely, and then it fits together in a way that we've digitally modeled and actually include instruction manuals for everyone assembling it so they actually know where everything might need to live.
So you talked earlier about the use of advanced construction materials for this house. So tell us a little bit about some of the materials that are being used and why they're advanced and what benefits they have.
Well, again, some of them, so we're referencing, again, the building envelope. It's a material that's been around for a while. It's a particular polymer-based product. It's a foam product, actually, that they're using for most of the walls of the house. But what's interesting about this particular foam-based product is it's 100% recyclable. A lot of the kind of plastic or foam-based products that you see out there, once they're in the universe, well, that's it, right? They're kind of there, and they're going to eventually pollute this planet, right? Leading to greater waste, and it's a problem we have to face together as a people. In contrast, this particular system can be completely reconstituted and reused over and over and over and over again. And so there's a particular material innovation there. I think most of the other things, we're actually trying to use very common materials, and that's one of the reasons we're able to achieve great environmental benefit while also achieving a radical reduction in cost, about 20–25% in cost of the house, is we're able to do that because we're not using super fancy innovative materials by and large. We are using very high efficiency energy equipment. And so the way that we're heating and cooling the house is going to use less energy to achieve greater ends. We're including a radiant floor slab heating system, which is a wonderful system where you actually run the heat in the slab of the floor itself. So the heat emanates up through you because heat likes to rise. So it generally keeps the heat where the body is. So more using smart techniques and technologies from all over the place and bringing them together. And I think that's what we really contribute is we're not inventing anything. We're just bringing a lot of really smart things together in a way that's not been done before. And it's hopefully leading to a product that has a high degree of intelligence. Not because we do, but I guess we're friends with lots of people who are.
So tell me a little bit about the building site. I know that presented some unique challenges to you, and that was something you actually sought out kind of on purpose.
Yeah.
And so what form, what shape is the house going to take?
So the building site itself is in Corktown here in Detroit. We're really excited to be building in that area. It's a neighborhood that's received a lot of attention of late, and a lot of really interesting work going up there. So we're excited to be a part of that assembly. But we did choose a very, very narrow lot for our first house, and that was intentional. We are attempting to design in a way where it's not the traditional approach of architecture, where an architect creates a custom product for an individual client, and then they move to the next client. It's a new custom product. We're actually trying to design this as a system. And as we design a single house, our mind is actually thinking about house 300 and house 600, and how house 600 becomes smarter through the work we're doing in house 100. And we have that conversation all the time. Saying, okay, this is something we've learned. This is how the second one will be better. And then when we do 4 at once, how all of them will improve from that kind of scale. And so for us, a really, really narrow site presented a wonderful difficulty, meaning if you can design for a really confining condition, then when you have a less confining condition, chances are that same strategy will also work. Whereas the inverse is certainly not true.
So when you get into scale, is that also going to reduce the price? Did you get as economies of scale, I assume? Yes.
Right. And that's one of the reasons we're prioritizing digital fabrication, offsite construction, because the imprint in terms of time and money on those modalities of construction will, when you scale up, will be far greater. And that stands in sharp contrast with, like, let's talk about stud-based construction, which we still use. Like, if you're building a house and the studs show up on site, well, they're going to be, 2 by 4 by 8 feet long or 12 feet long, whatever you spec. When you go build that second house, you're getting the same stud arriving onto the site, the same 4 by 8 sheet of OSB, whatever it may be. It's no more or less intelligent than the OSB that populated the first site that you were working on. In contrast, when we're digitally fabricating and we have a digital model of every component that we're building into the house, well, the second one we built actually does have smarter, more detailed componentry arriving on site, because that componentry is learned from the first house and the third house and the fourth house. And so it's very much like you see in the automotive industry, where the first couple trucks off the assembly line might not be sold, but they sure tell you a lot about how the next set of trucks might actually become a little bit better.
Is this machine learning or AI, or what is this?
So we're fascinated with AI, and I actually have a research agenda that's still here at LTU, where I'm looking at how AI might be leveraged to allow communities to have greater input in the development of neighborhoods. And I'm pursuing an NSF grant with some colleagues here to actually be able to fund that and pursue that. At home, we are fascinated by AI, but right now we're focused much more on generative design, where you are developing algorithms and scripts to help you make smart decisions based on things like where the sun is, where view angles might be, et cetera, knowable factors. And so at this point, we haven't had to leverage the intelligence of AI yet, but we're actually pretty amped to do so when required.
Okay. And you're looking to build a lot of these houses, right? Based on what you learned from this first one, you would like to turn this into an ongoing sort of development business for more affordable housing, right?
That's absolutely true, but we don't want to do it in the same cookie cutter way that so many of our suburbs are done, where each house is a kind of an identical version of the one preceding it, maybe a slightly different shade of taupe, but the same house by and large. Like, that's not. Our houses can be custom tailored to each site in context because of the algorithm I mentioned, because the solar positioning and where the trees are and where the views are and how your neighbors' houses are built, the form they take, all these things change from neighborhood to neighborhood or neighborhood. And I know that housing, at least the housing at the price point we're talking about, can't accommodate the expense of architectural design services in the kind of traditional way. But if some of the intelligence of the architect can be embedded in an algorithm that could generate a result that showcases that intelligence in seconds, then we might be able to get a better position, a more contextual version of this kind of mass production that we've seen so often in our suburbs.
All right, we're coming to the end of the segment, so tell us a little bit about how people can learn more about houm and what you're doing.
Well, I think the best way is to go to our website. It's ourhoum, or OURHOUM.com. If you're on Instagram, you could follow us under the same handle. Just put a underscore between R and home. And you can also reach us. We're currently partnering with 3 Squared International that has a history of working with container-based architecture, and they're kind of broadening, and they've embraced us and really kind of helped us along. So you can go to the 3 Squared website as well and find out more information about us there.